Hey everyone, today we are going to be dividing multi-digit decimals. So in this cloud over here, it gives you some important information about being able to divide a decimal by a decimal with multiple digits. So it says when dividing by decimals, it is easier to complete the division when the divisor is a whole number. This number here is the divisor. It's the one that's doing the dividing, and we want that to be a whole number. In order to make that a whole number, we want to multiply both the divisor and the dividend by the same power of 10 so that the divisor is the whole number. So again, we're going to focus on making this number the whole number, and the dividend is going to be changed just because we have to do the same thing to one that we do to the other. When we talk about multiplying by powers of 10, this moves the decimal. So if I multiply by 10, it moves the decimal one place. If I multiply by 100, it moves it two places. If I multiply by 1,000, it moves it three places, and so on. Okay? So for this one, I'm actually going to multiply 0.12 times 100 because I want the decimal place to move twice. And if I do it over there, I have to do it over here. So what that's going to do is it's going to take my decimal and it's going to move it two places to the right. It's going to take this decimal and move it two places to the right. So this becomes 0.6 divided by 12. And again, this number is the whole number. So now I'm going to do my long division. So 12 into 0.6. My decimal is already here, so I'm going to bring it up to the top. 12 does not go into 6, so I'm going to put a 0 on top. And then instead of bringing down a 0, I'm just going to annex a 0 in and do my division. So 12 goes into 60 5 times. 12 times 5 is 60. When I subtract, I get the 0 that I want. So the answer to this division problem, 0.006 divided by 0.12, is 0.05. Okay, this is the same as everything else that we do in math. When we do it to one, we have to do it to the other to keep things the same. So now we're going to do a couple more of these. So this one, 60.927 divided by 0.012. I'm actually going to be multiplying this, so 0.012 times 1,000 to move the decimal place 3 times. And if I do it to that side, I have to do it to this side as well. But all I'm going to show this time is that I'm moving the decimal. So this is going to move 3 times. 1, 2, 3. This is going to move 3 times. 1, 2, 3. So that my new division question is 60,927 divided by 12. And now this problem, so I'm trying to make this a whole number. So now this problem looks very similar to what we did earlier this week with long division. So I've got 12 on the outside, 60,927 on the inside. 12 goes into 60 5 times, so that's going to work out really nicely to start. 12 times 5 is 60. When I subtract, I get 0. So I'm going to bring down the 9. 12 does not go into 9. So I'm going to put a 0. And I'm going to bring the 2 down right away. 12 goes into 92 7 times because 7 times 12 is 84. And you can use your multiplication chart for the 12s. So now I'm going to subtract. 12 minus 4 is 8. And I'm going to bring down the 7. So it goes in 7 times again because 12 times 7 is 84. So I'm going to subtract. 87 minus 84 is 3. And now I'm going to start annexing my 0. So I'm going to add a decimal place and add my first 0 to bring it down. 12 goes into 32 times because 12 times 2 is 24. And I subtract. 30 minus 24 is 6. I'm going to put in one more 0. And 12 goes into 65 times. When I subtract, I get that nice 0. So the answer to this division question, 60.927 divided by 0.012, is 5,077.25. Okay, one more question over here. This one I want to multiply by 100 to move the decimal place twice. So 1, 2, 1, 2. So 294.3 divided by 27. And again, my primary focus was to make this number the whole number. So 27 into 294.3. 27 goes into 29 one time. Uh, 29 minus 27 is 2. I bring down the 4. 27 does not go into 24, so I'm going to put in a 0. I'm going to move my decimal point up since it's already there and bring down the 3. And then 27 times, let's try 8. 8 times 7 is 56, carry the 5. 8 times 2 is 16. Plus 5 is 216. So let's try 27 times 9. 9 times 7 is 63. So carry the 6. 9 times 2 is 18. Plus 6 is 243. Okay, so 9 works. 9 times 27 is 243. And when I subtract, I get that lovely 0 that I wanted. So the answer to my division question is 10.9. Down here at the bottom, I've just got a little bit of a word problem. So it says Mr. Gonzalez has $4.05 left from buying his pears and plums. If oranges cost 52 cents per pound and carrots cost $1.21 per pound, how many pounds of each could he buy with his remaining money? So I want to know for the oranges, if he has $4.05, how many pounds of oranges could he buy with 52 cents? And then not pears, it's carrots. And if I've got carrots and it's $4.05 divided by the cost of the carrots, $1.21 per pound. So for this one, I'm going to move the decimal place over 2 times. So it becomes 405 divided by 52. Same thing over here. 405 divided by 121. So 52 into 405. I think I'm going to try 3. So 52 times 3. 3 times 2 is 6. 3 times 5. That's too small. Way too small. Let's try 52 times 7. 2 times 7 is 14. Carry the 1. 7 times 5 is 35. 36. If I do 52 times 8, 8 times 2 is 16. 8 times 5 is 40. So 416. So 7 is where we're going to start. because 416 is too big. So 7 times 52 is 364. And I subtract. So 5 minus 4 is 1. 10 minus 6 is 4. And this one I've got to annex zeros right from the beginning. So I'm going to bring down a 0. 416 is still going to be too big, so I'm going to go with 7 and use 364 again. So 6, 4. I'm going to bring down another 0. So this one I can use 416, it looks like. Let's try 52 times 9 just to be sure. 9 times 2 is 18. 9 times 5 is 45. 468 is too big. So I'm going to do 8. And I get 416. So 440. Oh, sorry, 44. And I'm going to bring down the 0. 468 is still too big, so I'm going to go with 8 again. So minus 416. 10 minus 6 is 4. 2, and then I'm going to add a 0. So 240. 7's at 364, so let's try 52 times 4. 8. 4 times 5 is 20, is 208. Let's try times 5. 5 times 2 is 10. 5 times 5 is 25, 26. That doesn't work, so it's going to be 4. And I'm at 208. 3, 10 minus 8 is 2, so 320. So 52 times 6, let's see how close we can get. 12, carry the 1, so 312. If I bring down another 0. So it looks like this one's going to go for a while. And we could probably just keep dividing and dividing and dividing. So I'm actually going to stop here just for the sake of time and energy. So it says, how many pounds of each could he buy with his remaining money? Well, we can stop here for the oranges. And eventually we would have rounded this number anyway because it just keeps going and going and going. So I'm going to go over to the other one. So I'm going to do 121 into 405. Let's try 121 times 3 and see where we get. 363. Because I think 4 is going to be too big. It's going to be 484. So we're going to go with 3. And I've got 363. 5 minus 3 is 2. 10 minus 6 is 4. And I have to annex my 0 right away to bring it down. 4 is still going to be too big, so we're going to go with 3 again. So 363. 10 minus 3 is 7. 11 minus 6 is 5. So let's try 121 times 5. 5, carry the, nope, 5 times 2 is 10, carry the 1. 5 times 1 is 5 is 6. So this is 605, so we're going to go with 4. And 121 times 4 is going to be 484. So 6. 86. So I'm going to bring down a 0. So let's do 121 times 7 and see what happens. So 7 times 2 is 14. 7 times 1 is 7, 847. So that works. So 847. 10 minus 7 is 3. So if I bring down another 0, it's going to go in 1 time. So 2, 10 minus 1 is 9. And again, this one looks like it's going to go for a ways, so I'm actually going to stop because we would eventually round. So I'm going to stop here and call it that it's good enough. So how many of each could they buy? Well, they could buy 7 and almost 8 pounds, so 7.78 pounds of oranges, and then 3.3471, etc. pounds of carrots. So these two are an example of ones that just kind of keep going and going and going. And we could just keep going and going and going, but we would eventually round it to get our solutions. The main objective here is that we are moving that decimal, so multiplying by a power of 10. Again, multiplying by 10 is going to move it once, 100 moves it twice, 1,000 moves it 3 times. So I have an example of where you had to move it twice. This example A down here, for example 2, you had to move it 3 times, and then in part B, you had to move it twice again. And again, you're trying to get this second value to be your whole number. So multiply both the divisor and the dividend by the same power of 10. So the divisor is the whole number. Okay, this goes along with your other operations of multi-digit numbers, and your homework is in the textbook today. Good luck.